Hello and welcome back. All right, so here's an example. How to calculate the derivative of y equals x squared. So it should have already come into contact with this. The definition of the first derivative gives us a slope at one point, and this process can be long and tedious. However, actually performing it is actually fairly straightforward once you get the hang of it. So if we look here, let's look at this expression. There's three pieces. There's f of x, which is given. So here, this is f of x. Y is f of x, given. So we need to find this. We have to find this. And then h is just h. Just h. In other words, there's nothing to calculate. It's just h. Okay? And f of x is given. So the only thing that we really have to think about is how to figure out f of x plus h. And what, okay, let's be very clear. F of x plus h, what that means is replace x with x plus h. Okay, well, f of x is x squared. F of x plus h, just replace x with x plus h. We get x plus h squared. And thankfully, before we were in calculus, we took a bunch of courses in algebra. So x plus h squared is no big deal. We just take x plus h and write it twice and do the multiplication. So, right? X times x is x squared. X times h is xh. Plus x times h again is xh. Plus h times h, h squared, right? All I did was this. I just did good old algebra. Boom, 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 and boom. That's it. And then, simplify if possible. xh plus xh. That's 2xh plus h squared. All right, well, there we go. There's f of x plus h. So let's plug everything in now. Okay? So we're plugging everything in. M is going to be the limit as h approaches 0, and we're just going to substitute everything in. F of x plus h, we know what it is. We found it. There it is. I'm just going to plug it in. X squared plus 2xh plus h squared minus f of x, which is given. It's just x squared minus x squared over h. Okay. And now this should happen every time. Every term involving every term non-involving h should go away. So let's check this out. We got x squared. We're going to search for like terms. Not a like term, not a like term. Looky here. X squared minus x squared goes away. So all we have left is 2xh plus h squared over h. Something I forgot to mention, oops, is see if you can plug in 0 for h first. Okay? In other words, look. If h is 0, we get 0 on top plus 0 here. 0 plus 0. But then we get the 0 on the bottom. So the thing that we're trying to do here is we're trying to get rid of the h on the bottom. Because as long as this thing is continuous, then to find the limit, all you got to do is plug in 0 for h. But if we have 0 over 0, that's indeterminate. So to determine what it actually is, we have to get rid of the h on the bottom. That's what we're trying to do. Okay? And every time you do this, the terms not involving h should go away so that you can factor. So again, I'm trying to cancel the h. I'm going to factor that from the top and bottom because I'm trying to get rid of it. So if I factor in h from 2x h, I just have 2x left plus h over h. And now look, boom, boom. H over h is 1. So we get limit as h approaches 0 of what's remaining, okay? And that is 2x plus h. Okay, now notice there's no h in the denominator. So, okay, let me say one more thing. There's no h in the denominator, and these functions are continuous. 2x is continuous. H by itself is continuous. So to find this limit, we can use the continuous function theorem. Continuous function. I'll call it the continuous function limit theorem. I'm just going to plug in 0 for h. So I get 2x plus 0, which is just 2x. Okay? And so what we've discovered here is that the slope, which again is dy dx, which is f prime of x, is different notations for the same thing, df dx, is 2x. Okay? So that's the calculation. Now let's talk about some of the consequences. Make sure that we actually understand what's going on. Okay? So here's my little x and y grid. X, y. We know what x squared looks like. Like this. Okay, now what this is saying is that the slope at any point on y equals x squared is given by twice the x value. Okay? So let's check a couple things. Without doing any math, we can see visually, we can see here that the slope, if I draw a little slope here, we can see here that this line is falling. In other words, the slope here is negative. And also, as we come in towards 0, we can see that the slope is getting less negative. In other words, the slope up here is steeper, negative, and the slope down here is shallower, but negative. Okay? So here, the slope is still negative, but the slope is approaching 0. Okay? Alright. Now what about here? What about at 0? Okay? At 0, the slope is exactly 0. Okay? Slope is exactly 0. Here we can see it. And does that agree with our formula? If I plug in 0 for x, I get 2 times 0, which is 0. Okay? What about something like over here? Like if I plug in -4, I get 2 times -4, which is -8. Versus, let's say something like here. Like -1/2, for example. If I plug in -1/2, I get 2 times -1/2, which is -1. -1 is certainly going to be less steep than -8 for a slope. As we keep moving to the right, hopefully here we can see that the slope is positive. And if this single point thing is kind of confusing, then think about 2 points. Think about 2 points that are close together. If I draw a slope between these 2 points over here, slope is going to be positive. Okay. And as we go this way, we're steeper and we're positive. Again, if x equals 10, we get 2 times 10, which is 20. Versus x equals 1, we get 2 times 1, which is 2. So the point is that the formula agrees with what we're seeing graphically. Okay? So hopefully this is making sense. Let me know if not.